Welcome to another video related to the chapter Equilibrium. If this is the first time you've been here, definitely check out other content that I have in this channel. I basically deal with class 11 and 12 CBSE chemistry, right from NCERT questions to concepts. So in this video, also definitely let me know if you need help with anything and also interact with the video, and that gives me joy, and that's all I can ask of you. So in this video, we are going to be talking about hydrolysis of salts and the pH of their solutions. So basically in your, we are almost done with the chapter Equilibrium. It just took me 2 years, it's fine. But basically this concept is really important because it gives you an idea about the acidity and basicity of different solutions. So first of all, this particular thing that you see here, I'm sure you know what it is. If you did do, that's amazing. It's the neutralization reaction. So an acid plus base gives rise to a salt and water. When we have acids like, let's take an example. For example, we're taking acid like HCl and we're mixing it with sodium hydroxide. We get sodium chloride plus water. This is the neutralization reaction. In this reaction, the sodium chloride that is formed, it's the salt. So the salt solution of sodium chloride is neither acidic nor basic. So it's a neutral solution. However, there are salts which are formed which could lead to either forming an acidic or a basic solution. Okay, so basically what I'm trying to say is that the strength of an acid and a base that get mixed to form salt, that determines if the salt solution is going to be acidic or basic. First of all, let's deal with the easy parts. The cations of strong bases like sodium Na+, potassium ion, calcium ion, and barium ion, all of these are cations of strong bases. These are a few examples which are mentioned in your textbook. And the anions of strong acids, I forgot to mention strong acids, it's fine. Strong acids, all of these lead to the formation of a neutral salt. This is because they do not undergo something called as hydrolysis. Okay, so the anions and cations of strong acids and strong bases do not undergo something called as hydrolysis. And the hydrolysis, I actually found this very helpful definition in modern ABC's textbook. So basically, the interaction of an anion or a cation with water leads to the formation of an acidic or basic solution. Okay, this might not make a lot of sense right this second, and that's fine. So what I'm trying to say is that when you have a weak acid or a weak base, this leads to this leads to a formation of salt, which may or may not cause the solution to be acidic or basic. Now let's take examples and then go from there. We're going to start with the weak acid plus strong base. Now the salt we are going to consider for this is the sodium salt of acetic acid. So CH3COO Okay, now the weak acid here is going to be the acetic acid. Okay, and a strong base is going to be sodium hydroxide. Okay, so this is the example we're considering. Now, when we have the salt and let's add it to water. So when this particular salt is in, sorry. I am sorry. No, that didn't work. It's okay. So CH3COO Na in aqueous medium is going to give us CH3COOH. Okay. Oh, CH3COO minus, because it's going to be in the ionic form. So CH3COO minus and Na plus. Now, this Na is a cation of a strong base. So it won't again interact with the water molecule. However, the CH3COO minus does not like staying in the ionic form. So what it will do, it will basically combine with the water. And this leads to the formation of the acetic acid. Okay, but because it's forming the acetic acid, you're left, when you have H2O, you're left with the OH minus. And CH3COOH usually prefers, the acetic acid is a weak acid and it prefers to stay in the unionized form. Okay, for the most part, it's going to be unionized, which means you have an excess of OH minus ions. And this OH minus ion is going to cause this solution to be basic. Okay, so basically, because the Ka value of acetic acid is 1.8 into 10 to the power minus 5, it prefers to stay in the solution, and this leads to an excess of OH minus ion, which makes the solution basic. Okay, now I'm just going to write the final reaction. So it's CH3COONA plus H2O is going to be in equilibrium with CH3COOH plus Na plus OH minus. Remember, this sodium ion is not going to again hydrolyze with the hydroxide to form our base. That's the whole point. So because it's a cation of a strong base, it won't do that, and so it's going to stay as Na plus. However, that's not true for our weak acid. Let's go on to study another example, which is going to be a strong acid and a weak base. The strong acid we are going to be considering is HCl, or I should say a salt of a strong acid and weak base. So HCl, and the weak base is going to be NH4OH. So NH4OH and HCl. Now this is going to give us a salt NH4Cl. Okay, now the exact same thing which we discussed over here is going to happen here too, but in a slightly different way. Now when we have NH4Cl, this in water is going to give us NH4 plus Cl minus. Okay, I should be better about writing this. It's okay. So NH4 plus Cl minus. Now this NH4, again, because it's a weak base, it does not want to stay as NH4 plus. It prefers, and again the Kb value for NH4 plus or NH4OH is actually 1.8 into 10 to the power 5 minus 5. So because of that, it still prefers to stay in the unionized form. So NH4 plus combines with H2O and is going to be in equilibrium with NH4OH plus H plus. Okay, because this H2O, OH has gone to NH4, so you're left with H plus. So this in turn makes our solution, if you guessed acidic, you are absolutely right. So essentially what's happening here is because of the excess of the H plus ions, this leads to our solution being acidic. Okay, now the final solution or the final equation can be written as NH4Cl plus H2O is in equilibrium with NH4OH plus Cl minus plus H plus. Okay, and remember one thing, the Cl is a anion of a strong acid. So this is not going to undergo hydrolysis to form HCl again, right? So that's one very important thing to remember. Both Na plus and Cl minus, both of these are cations and anions of strong acids respectively. And they're not going to undergo the process of hydrolysis. The last example is going to be a weak acid and a weak base. So we are going to consider CH3COOH, and a weak base is going to be NH4OH. I'm pretty sure my laptop's battery is low. It's fine. It'll be fine. NH4OH. So the salt we're going to consider is CH3COONH4. In this case, you cannot make a generalization. In this case, your solution can either be acidic, it can be basic, and it could be neutral. This is because it depends on the strength of our weak acid and weak base. Based on the strength of our weak acid and weak base, the final salt solution could be either acidic, basic, or neutral. Now, obviously, we're going to do the same thing that we did for the others. We're going to write the equation. So CH3COONH4, right? CH3CONH4 aqueous is going to give us CH3COO minus aqueous plus NH4 plus, right? Now, this CH3CO minus NH4 plus is going to be, oh, let me rewrite it. It's fine. So CH3COO minus plus NH4 plus. I apologize. Okay. That's much better. So I apologize. I basically put my laptop on temperature. It's fine. So CH3CO minus NH4 plus H2O is going to give us CH3COOH plus NH4OH. Okay, now one thing you need to remember here is that I've always said that these guys prefer to stay mostly unionized, which means there is a percentage or a small amount of it which could be in the ionic form. This is why the strength of these acid and base matters. In this case, it didn't matter because the respective acid and base were strong. Because of that, in comparison to that, these guys are obviously going to be weak, and so that's all we have to consider. Here we are going to have to consider the relative acidity and basicity of these of the weak acid and the weak base. So these are the following things that are possible. So CH3COOH could be in equilibrium with CH3COO minus plus H plus. You have NH4OH could be in equilibrium with NH4 plus OH minus, and then you also have the water molecule. So H2O is equilibrium, H plus OH minus, right? So this is why the relative strength matters. Just about few minutes ago, I mentioned that the Ka value and the Kb value of NH4OH and CH3COH, basically Ka of CH3COOH and Kb of NH4OH is equal to 1.8 into 10 to the power minus 5, which means they are almost equal in strength in terms of an acid and a base. This in turn means that the end solution, in this case, the salt solution is going to be neutral. Okay, so basically the strength of the acid and the base dictates if our salt solution formed is acidic or basic. In the end of your of this topic, we have been given one very important equation. The equation given is pH of this particular solution is going to be 7 plus half pKa minus pKb. And our textbook was very helpful. They said you don't need to know the math, and that's perfectly fine. Our focus right now is just understanding the concept that goes behind this. And if you want a more detailed video, definitely let me know. But basically, pH is equal to 7 plus half pKa minus pKb. Now, another thing that they've mentioned is that the degree of hydrolysis is independent of concentration. Notice we've not considered the concentration when we wrote the equation for the pH. It only depends on the strength of the acid and the base. So pH, the value of pH will be greater than 7. So essentially it's going to be basic when pKa minus pKb is equal to a positive value, which essentially means if we have a strong acid, basically this means the pKa value is great. pKa minus pKb is positive, and in the other case pH is going to be less than 7 when pKa minus pKb is all equal to negative value. Okay, so essentially the hydrolysis of salts and the pH solutions, the strength of the acid and the base determine if the solution that you get is acidic or basic. Right, and we consider the first example. First of all, when you have strong acid and a strong base, you have a strong, like a neutral salt that's formed. So sodium chloride, it does not undergo the process of hydrolysis. Hydrolysis is a process where a cation or an anion interacts with the water molecule, making a solution acidic or basic. So we considered the first example, which is weak acid and a strong base. So in this case, the solution that came up was basic. And then you have strong acid and weak base. You have the solution coming up as acidic. And then you have weak acid and weak base. This, based on the strength of the acids, can be acidic, basic, or neutral. In the end, we were given that if the pH is greater than 7, pKa minus pKb is positive. If it's less than 7, pKa minus pKb is negative. I hope all of that made sense. In the next video, we are going to be discussing buffer solutions.